Hi, my name is Dr. Deshawn. In this video, we are going to evaluate a definite integral using the u-substitution method. Let's take a look at this example right here. We're going to integrate from 0 to 1, and then it's x times the quantity x squared plus 1 quantity cubed. So let's start by actually doing the integration. We want to integrate, you have a couple of options here. You could expand and multiply it out, but we're going to utilize the integration by substitution method. We're going to use a u-substitution. The letter u is what we're going to use to represent a part of this integrand, all right? Now, what do we let u equal? You're going to let u equal the inner part of the composite function, the inner part of the composite function. So when you're looking at the integrand, the inner part of the composite function is going to be the quantity that's inside the parentheses or the quantity that's under a radical if you're dealing with a rational expression. So we're going to let u, the letter u substitution, we're going to let letter u be the inner part, the inside the parentheses, x squared plus 1, the inner part of the composite function. Then what we want to do next is we want to get the differential of u. So to get differential of u, differential would be du. So the left side is going to be du, use differential. On the right hand side, we want to take the derivative. The derivative of x squared plus 1 is going to be 2x plus 0, and then times dx. All right, so u substitution, u is going to be the inner part of the composite function, which is the quantity inside the parentheses in this problem. Then we want to get the differential. I like to go one more step. I like to get dx by itself. So to get dx by itself, I'm going to divide both sides by 2x here. So du over 2x, and that's going to be my dx substitution. All right, so here are the pieces that I need to make my substitution. So next what we want to do, I'm going to rewrite the integral. So I'm going to rewrite the integral. I'm going to get the x's out and substitute all my u quantities in. Now, I'm not going to put bounds on this definite integral. I'm not going to put bounds here by 0 to 1 because technically they would be different if it's in terms of u. We're going to talk about that when we evaluate this, okay? So let's go ahead left to right and read the integrand. We have an x and nothing substitutes for the x. So just bring the x down. All right, what do we have next? X squared plus 1. Well, that's what we're calling u. So we're going to substitute u in for x squared plus 1. We're going to put a u, and that u is raised to the third power, okay? And then we have dx here. And dx, we have a substitution for that as well. dx is du over 2x. So we're here. All right, now what do you see? You see the x's cancel, and that's exactly what we need to do is we need to cancel out these x's. All right, we have to get rid of the x's. When we're using u substitution, you're going to have to get the x's out of the integrand, and you're going to have to substitute the u's in. Okay, so what do we have now left over? There's a constant, the 2 in the denominator, and I like to pull those constants up front, all right? So the 2 in the denominator, you can pull constants outside of the integration sign, but you can't pull variables out. But constants, it's okay. All right, so pull the constant 1/2 out front, and what do we have? We have u cubed at du. All right, so now we're just ready to go ahead and use our power rule to integrate this. So you have the 1/2 up front. Integrate u to the third power, you're going to get u to the fourth power over 4, just using the power rule. All right, so and then if you want to merge together your denominators here, we can call this 1/8 u to the fourth power. All right, now no plus c on here because we don't need a constant of integration. We have a definite integral that needs to be evaluated. So what we're going to do next is we're going to evaluate this, but I want to show you there's 2 different methods that we could use to evaluate. Okay, so now we've got to work with the bounds. Now we can write this in terms of x, leaving the bound 0 to 1, or if you wanted to evaluate in terms of u, you would have to change the bounds. Let's take a look at both of these, okay? So we want to now take this expression right here, the 1/8 u to the fourth power, and we're going to, there's 2 different methods we can use to evaluate. Let's take a look at both, okay? So there's 2 ways to evaluate. Okay, and we're going to look at both. I'm going to call it method 1. All right, and method 2. I'll put method 2 over here. Okay, so now we're all set up. All right, let's take both. Take a look at both. So what do we have here? We have 1/8, and we have u to the fourth power. That's what we have here. Okay, so we want to evaluate this. Our bounds are 0 to 1, but 0 to 1 if it's in terms of x. So if you want to evaluate this expression, all right, this is what we have. If you want to evaluate this expression and you want to use the bounds from 0 to 1, you're going to have to rewrite this back in terms of x, okay? So let's do that. So you have the 1/8, and we have u to the 4th power, okay? All right, but what is u? Because we need to flip it back to our expression in terms of x. U is x squared plus 1. So you would have to change u back to the x squared plus 1. And once you get the u changed back to the x squared plus 1, now we can go ahead and evaluate this from 0 to 1. We can use our x bounds because we changed it back to in terms of x, okay? So now let's go ahead and compute this. All right, so we're going to use the fundamental theorem of calculus, okay? So plug in the upper bound, you get 1/8, okay, times 1 squared plus 1 to the 4th power, all right, minus plug in the lower bound, and you get 1/8 multiplied by 0 to the 2nd plus 1 to the 4th power, okay? So, all right, so you get my grouping symbols on here. So we went ahead and we took this expression, plug in the upper bound for our variable, minus plug in the lower bound for our variable. That's your fundamental theorem. And compute. So we have 1/8 here, multiplied by, this is 2 to the 4th power. So 2 times 2 times 2 times 2, there's 16. And then here you have 1/8 times 1 to the 4th power. Okay, so 1/8 of 16, so this is 16 over 8, I'll leave it like this, so this is 16 over 8, and you're taking away 1 over 8, okay, so keep the denominator, combine the numerator, so 15 over 8, and there's your final answer. So your final answer, we're evaluating this definite integral, the final answer is 15 over 8. All right, now what we did here is we actually took the u, changed it back to the x squared plus 1. We took the u and changed it back to in terms of x, so we can use the 0 to 1 bounds, okay? Now, what if you don't want to change it back? What if you want to evaluate this with the u in there? Sometimes it's easier if your u substitution is a really busy expression, sometimes it's easier to just leave in terms of u. So what do we have? Method 2. So this is 1/8, and it's u to the 4th power, all right? And so we want to evaluate this, okay? So this is going to be 1/8, okay, and u to the 4th power. So let's evaluate this, but we can't use 0 to 1 because 0 to 1 is what we do when we have x's, okay, not u's, all right? So we have to change the bounds. Well, what is the lower bound? The lower bound, so when x equals 0, the lower bound is 0 in terms of x. When x equals 0, then what's the lower bound in terms of u? Well, your u substitution is take the x and square it and add 1. Okay, so when your lower bound in terms of x is 0, but what's the lower bound in terms of u? It's going to be the x squared plus 1. It's going to be 0 squared plus 1, so it's going to be 1. Okay, your lower bound in terms of when x is 0, u is 1. You have to change the bounds, okay? So what about the upper bound, okay? So the upper bound when x is 1, in terms of x it's 1, okay? So the upper bound when x equals 1, okay, when x equals 1, what is our u bound? Well, take the x and square it and add 1. So your upper bound in terms of u is going to be, let's see, plug in the 1, so it's 1 squared plus 1, so it's going to be 2. Okay, so that's going to be the upper bound in terms of u. Okay, so in terms of x, you're going to evaluate from 0 to 1, but in terms of u, the bounds are going to be from 1, all right, to 2. Okay, so the bounds are going to be from 1 to 2. Don't know if this is showing up well. All right, so we're going to evaluate this from 1 to 2. All right, so we have 1/8. And we have u to the 4th power, but this way we're going to evaluate from 1 to 2. We use our fundamental theorem of calculus, but evaluate from 1 to 2 in terms of the u, okay? So let's go ahead and use the fundamental theorem of calculus. So you're going to plug in the upper bound, which is 1/8 times 2 to the 4th, all right? Minus plug in the lower bound is 1/8 times 1 to the 4th, all right? So in terms of, so do you see what we're doing here? So in terms of x, if you want to use the bounds at 0 to 1, then you got to change u back to x, and you can use 0 to 1. All right. So, but if you want to leave it in terms of u, and sometimes when this expression is a little bit involved, sometimes it's beneficial to leave in terms of u. If you want to leave this in terms of u and evaluate in terms of u, then you have to take what your u substitution is. You have to take the bounds and plug them in, change the bounds, okay? So in terms of x, the bounds go from 0 to 1, but in terms of u, the bounds go from 1 to 2, okay? So plug in the upper bound 2, 1/8 times 2 to the 4th, minus, and then plug in the lower bound 1/8 times 1 to the 4th, okay? And here you're at 16 over 8, okay? Minus, evaluate this, 1 over 8, and then keep the denominator, combine the numerators, so you end up with 15 over 8. So whether you change back to x, use the bound 0 to 1, or leave in terms of u, change the bounds, okay? So if you're going to leave in terms of u, then you need to change the bounds. All right, to evaluate, all right? So if you're going to change, if you're going to leave it in terms of u, don't forget to change the bounds, okay? And that's it. So here is integration by substitution. We use the u substitution to evaluate, and then we use the fundamental theorem of calculus to evaluate this integral to get our answers. 2 ways: leave in terms of x, all right, or change to u, all right? And that's it for this video. So thank you very much. Appreciate it.